Good afternoon, everyone, and welcome to the Post-Secondary Climate Challenge webinar. My name is Natalie Milan, Program Manager, and we're excited to have you with us. This session is part of our cohort project, HVAC and BAS Optimization Guide for Post-Secondary Institutions. This project is sponsored by ISO with program sponsorship from Enbridge and technical directions from Enerlife Consulting. Next slide, please. Before we get started, just a few housekeeping notes. This webinar is being recorded, and please, if you would like to join the conversation, please use the Q&A to submit your questions. We will try to answer your question during the session, but any remaining one we will include it in the Q&A document, and we share it after the event. Please use the chat only for technical issues. And now to get started, I am delighted to introduce Ian Jarvis, our president. Ian?
Thank you, Natalie. And let's go to the next slide. Like all Climate Challenge Network events, and Post-Secondary Climate Challenge is a program of the Climate Challenge Network nonprofit. We begin all these events with our land acknowledgement that respectfully we acknowledge the ancestral and largely unceded territories of the Inuit, the Métis, and the First Nations people that share these lands with us. We're speaking from Toronto today. We're on a virtual platform speaking to folks across Canada, and you're all in different Indigenous communities. But I'm speaking from the traditional homes of the Huron-Wendat, the Haudenosaunee, the Anishinaabe, and the Mississaugas of the Credit River. And you may know that Toronto and all the way down to the islands and up through York region are part of Treaty 13 with Mississaugas of the Credit River, the Toronto Purchase. We sincerely hope in that context that the work we're doing today will contribute, the work we're doing and the work that you're doing, because you would not be on this webinar if you weren't actively involved in this space already, and we hope our collective work is contributing in a meaningful way to our common responsibility as stewards of the environment. Next slide, please. So you saw the title which Natalie had put onto this, Managing Energy Emissions and Utility Costs in Financially Challenging Times. We are very respectful of the situation that colleges and universities, both across Canada and in fact across North America, are facing today. From a financial standpoint, operating budgets are being pressed, capital budgets are being pressed, infrastructure issues are not going away, and at the same time, we and others are coming forward, asking everybody to step up and take climate action to make a meaningful response to the serious threats that climate change is increasingly posing on all of us. So we understand the challenges. When Amandeep's team looked at this, the intent was, within those challenges, what is the opportunity? So we're very aware of tight budgets, rising energy costs, and the emissions targets that many colleges and universities across Canada have set. And those emission targets, the climate doesn't care what struggles we have right now. It's pressing on in not in good ways. Those emission reduction targets will not wait. So we know capital dollars are scarce, but we know the utilities budget is the one area where you can release significant operational savings. That's what today is all about. We know that these kind of measures don't have long lead times in terms of planning and design. We can implement them immediately, that they deliver big savings, and we'll see more of that later today, and they can deliver them fairly quickly. So we can make a meaningful contribution to the operating budget challenges we have, and this is all, it's not about new infrastructure, it's not about capital investment, it's all about making the best use you can of the existing systems you've got. until perhaps happier times come and the capital funds will be available to do the major retrofits, to do the decarbonization projects that we know are necessary. So the opportunity is every facilities department, and we have dozens of you on the call today, can immediately make a contribution to operating budgets without spending a lot of capital dollars. That we can, despite the limitations, we can make real progress towards emissions reduction goals. And importantly, we can build organizational capacity to do this kind of work. We can get everybody involved, everybody taking part in the work that can be done, which, again, as this agenda unfolds over the coming years, will build confidence, will build trust, will build momentum as, again, the long-term energy transition. We're going to have a lot of work to do in the coming years. This is a chance to build internal capacity for that kind of work. So this is not about spending money. It's about making better use of the infrastructure, the systems, the equipment, the opportunities we have. Next slide, please. Want to provide, again, the context for this, that not everybody has the same size of opportunity. So those of you who joined us earlier this year for the Post-Secondary Climate Challenge 2025 report, we presented the most energy efficient colleges and universities that reported data either through Ontario's broader public sector reporting, which we mine the data, or have sent data directly to us to be part of this. This chart is simply the savings potential, assuming every institution would meet the top quartile targets that we think are readily available through the kind of measures we're talking about today. So again, not looking at capital retrofits, looking at operational improvements, making the better use of your building automation systems, optimizing control set points. So these essentially were our most energy efficient at the top of this chart. This is all percentage savings, percentage target savings, and the least energy efficient at the bottom of these charts. If you're part of that conversation, you should know who you are. Most of the colleges and universities on this call are on this chart, and some of you are more or less efficient. If you're not on this chart, we're happy if you want to send us your data and we can add this to us and tell you where your ranking is. But Amandeep's going to talk a lot later about starting with knowing your savings potential makes the business case, it quantifies the savings opportunity, it points you in the right direction. So we had 36 colleges and universities reporting in this year's report. The utility cost savings potential, again, to meet these top quartile, which we consider to be fairly modest targets, is over $118 million a year. So it's significant dollars. And from our standpoint, the emissions reduction, 62% emissions reduction, if everybody got to the top quartile, that's 284,000 tons of greenhouse gas emissions. That's a big number. It's a big deal. That's why Climate Challenge Network is in this space, because colleges and universities have a major contribution to make to national targets, not just your own targets. So this is the size of the prize. This is why we're focused on this. And again, the work we're going to talk about today can deliver a significant part of that $118 million a year. Next slide, please. The other, I guess, disturbing aspect of the report we presented this year is the reality we're going in the wrong direction. So we've got COVID effects or post-COVID effects and all kinds of factors in play here. But these tornado diagrams are the best visual representation we've been able to find of how we're doing from year to year. So this is 2023 year, the latest broader public sector reporting year in Ontario, compared to the prior year in 2022. Every horizontal line is a university or a college. And the green ones are those that made savings from in 23 versus 22. The red ones are the one where the energy, weather normalized, went up. And I don't have to describe it. You can see the picture there. Red is predominating. And in the top left-hand corner, overall, we were looking at well over 100,000 tons a year of greenhouse gas emissions reduction. We actually went backwards by 21,000 tons in total energy use, which is 4.1% of usage in that year across a significant number of colleges and universities. So there's enormous potential. We're going in the wrong direction. We're under tremendous financial constraints, and we need solutions. We need ways of moving forward. Today's webinar is designed to provide direction, insights, hopefully inspiration for moving forward around using the assets you already have. Next slide, please. So I'm going to pass it over to my colleague, Amandeep Dayal, who heads the engineering team that worked this through. I'm delighted to mention now, and I know he'll introduce Aman later. We have Aman Heha from Humber College, which is in the top decile of those benchmark charts. So already one of the top performers that is still finding substantial opportunities within their own facilities. So Amandeep, pick this up if you would and tell us the story.
Thanks, Ian. That was my punchline, but you stole it. It's okay.
I do that all the time, yeah.
Good afternoon, everyone. Thanks for joining us. And I think, as Ian pointed out, that the goal of this research is to identify the opportunities that are easy to implement, and then provide you with a guide that would help you implement these in partnership with your own team, with outside external consultant, contractor, as needed for your needs to fulfill this. We want to see the immediate savings as a means of this, and then we'll have a conversation with Aman and Mark as sort of a panel discussion to see some of the easy things that could be implemented, some of the things that are needed more sort of efforts, and how Humber is doing currently within their current portfolio. But let's go through this guide where we'll identify, let me see. Okay. So the overview and approach that we used, and again, thanks for ISO for being a partner and supporter of this kind of research work, where we worked with Humber, Polytechnic College, and Niagara College to do this cohort pilot project where we looked at the BAS as a functionality to understand what are some of the opportunities still exist within the building automation systems, and how could you actually implement them and continue to sort of see those savings through those measures. It's not just only about one-time implementation, but also to develop the processes that would help build this system within the facility teams that would help achieve those savings. So that's the initial piece of the work, was around finding the opportunities, and then we also looked in what are some of the opportunities, or what are some of the existing contracts that are out there with the building controls contractor and other parts that are critically engaged with the colleges on a different levels, and how do you improve those pieces of information that would help you achieve a consistent longevity around these measures. So we in terms of the methodology, it was simple, and we'll kind of go through that as well. So we looked at establishing the savings potential for the building types, and then we looked at the analysis from the building automation trend data and intermeter data to identify these opportunities for the different campuses that were part of this project. As you would expect, the key thing that came out of as there is that the BAS optimization, which revolves around optimizing the HVAC systems, heating, ventilation, boiler plant, chiller plant, does result in utility cost and GHG savings, as most of these are tied to each of these measures. The benchmarking did help sort of prioritize where to focus on, and also had a clear set of targets and the goals for the facility teams. And then eventually what we're trying to do is condense all of this information into the guides that would help optimize the other facilities to kind of take on this opportunity. The project have seen, and we'll show you some of the results that came out of the initial implementation. And it's a continuation in a process where Niagara is working on implementing those measures at their side, and Humber have implemented some of these measures already, which were uncovered in there. again, you will see similar sort of table of content. This is the draft version of this, and today's call is also to take feedback from everybody on this call. And if you find anything that has worked for you with identifying these measures, implementing these measures, please feel free to reach out to us, and we'll love to have your feedback. So the idea is today's presentation is going to focus on delivering what we see has been in sort of a table of content that would help you kind of do these measures and sustain them in your current facilities. And also we've documented where are some of the gaps that are identified in the existing contract that could be improved to further enhance the implementation of that. So we'll go through this table of content with focus on these measures, focus on the building on the automation sort of existing contracts. And also I'll talk about some of the sample sort of optimization checklist that's going to become part of this guide. So the purpose of this initiative was to, again, identify the gaps that are there in we find. First, finding out these measures within the system. Second, implementing them. And third, sort of what are current existing processes that are already there that could be leveraged to ensure that these measures that are implemented sustain for the longer period of time and remains in the system. So that was kind of the purpose and the scope of this engagement was with that in mind. And also we also try to find where are some of the issues that we kind of find in utilizing the resources that are available outside through outside networks for smaller, medium, and larger colleges. So we want to also we try to understand also where some of the gaps where some of the smaller, the medium college are not able to utilize some of these resources, whereas the larger colleges are. So we're trying to document those as well and try to bring that back through the programs that are offered by the utility companies. So there could be more to be done for the smaller and the medium-sized colleges where the resources are generally an issue when implementing these measures. So it all started with benchmarking and setting the energy targets for these facilities. And that is going to be one of the recommendations or part of the guide is as a footstep in identifying these opportunities within your college, university, campus, or a building, is to document what is your current EUI and what is your target for that building. As Ian pointed out, that even Humber College, who's at the top of the benchmarking chart with the top decile savings potential, there are savings to be found, and we'll show you a few of them that were uncovered during this process. So if you, as a simple starting process, if you're not sure your ranking on this chart, please reach out to Natalie. She can provide you your savings potential based on the post-secondary climate challenge network analysis. And then that could be your starting point to understand where the opportunities are. And you can apply the same principles to any of your buildings, colleges, or any of the campuses to understand how much the savings potential you are. And when we compare these EUIs against the top quartile, these top quartile targets are telling us mostly all of the savings above the top quartile is typically operational savings. So your savings potential that's coming from the post-secondary climate change analysis is solely most of the times based on getting those operational savings in your facility. So again, the benchmarking itself is going to get you to the roadmap of establishing the savings potential, and then the BAS is your starting point to identify these opportunities. And then we'll talk about more where do some of these opportunities exist and how you can use internal teams to start working on that immediately with some of these low-hanging or sort of the low-cost, high-potential measures that would help you deliver the immediate savings and build a team and an initial success story within your departments, within your college, within your campus that would help you achieve more and more of this as the savings start to materialize. So the common findings, and I think this list of next sort of 15 of these you would probably see typically applies to most of the buildings. And there's many other measures as we talked about, right? But could be your starting point to pick and choose 2 and 3 of these measures and see if you can easily implement them within your facility. The scheduling and setback is something that's is a very simple measure in most cases, and it's the one that gives you the highest sort of the buck in terms of implementing this measure at a low cost. And this is something that you can actually start doing without any external help. You don't need the BAS contractors. You don't need any external party to determine what are your current operating hours for each of your spaces, and then how do you set your HVAC schedule for that space. So internally doing that and setting that as a kind of the first action item for your team could go a long way, because you will immediately start to see the savings as a result of implementing these measures, where HVAC system is operating as the HVAC system schedule is not matched with the schedule for the particular space, classroom, department, and the campus itself. Other measures, the economizer control, which is again a focus of the BAS optimization, where we've seen that we either end up using, in some cases, more cooling energy because economizer control on each of their handling system is not working. So that also then applies to the outside air control as well, where it's easy to identify how much outside air are you bringing into for each of the air handling systems, and which is unnecessarily increasing your heating load in the building. These measures, again, you could easily identify through your building up sort of BAS graphics, and we'll show you a few examples as well. Static pressure control, outside air control, sequence of operations, all of these measures are very simple in some cases and gets complicated in other ones. We'll kind of walk you through as well some of these where the things are complicated. Again, the idea is to kind of take the list of these measures and then apply across your campus and see which ones you want to tackle as 2-3 items as a starting point. And then you can tackle the rest of them as you kind of develop that team, develop those resources to kind of implement most of these measures. All right, so yeah, a part of the research we looked at, as I said, looked at Humber Polytechnic College and also reviewed the Niagara 2 campuses, where we looked at these opportunities that still exist. This was at Humber, there was a focus of one particular building where recently applied building automation systems, and analysis was conducted to see where the opportunities are. So as you can see, they see that there's still opportunities with equipment running after hours. Again, fundamentally, that's the starting point we would recommend for every college and every university to look at it. Is your HVAC schedule matches with the actual sort of occupancy hours for those spaces? Missing inactive setbacks, we looked at, and now this gets to the control piece, where the BAS was set originally to reset the space temperatures, heating and cooling set points, but some of these were not following the control sequence of operations. Those were highlighted through the tenant analysis and also highlighted through the BAS schematics and screenshots, which again could be part of the exercise that should be a regular exercise with your team to look at these graphics with the intention of finding anomalies in there. Typically, these are reviewed when the anomalies or when there's an issue that is reported back to the team, but regularly there's a missed opportunity to look at these on a regular basis to kind of confirm if the measures that applies based on this are implemented or not, or the system is telling us differently when it's supposed to operate differently. So in this case, these are sort of the missed opportunities that were identified through the BAS graphics review only. You could see on this, if I could point my mouse, this is one of the screenshots of where on the graphics itself, this formula was presented or sort of added to identify what is the outside air percentage that should be, that's this system is currently bringing in. So in this case, this was, I think, is economizer mode, if I'm not wrong. And then the system was running at 57%, which is fine. But you will see in some of the cases during the winter time, if this graph exists and this calculation exists on your building automation system, you will notice that in the middle of the winter, if this outside air percentage is higher than what you would have what you would need for this system, you could easily identify that with just one graphics with this percentage, and then you can engage your team to fix that issue. So having this information readily available to you, to your team, will help you identify and implement these measures much more easily. Simultaneous in heating, cooling still existed in the buildings where the economizer cycle is not working. So that's again one of the measures that was identified as a part of this project. Static pressure reset are using critical zones. So this static pressure reset measure is actually one of the measures that provides not only savings on the kilowatt hours, but also the demand savings as well. Typically, the handling unit systems are set up in a way that the static pressure sensor or set point is arbitrarily set in the system, and the VFD is controlled using that static pressure set point. And typically, those are set at a higher value than they're supposed to. So understanding what should be your static pressure set point for each system so you can optimize to a point that it reduces not only your VFD speed during the unoccupied period, but it also reduces during the occupied period as well. So it helps you, if you're a Class A customer, as an example, it helps you on your global adjustment rates as well. Humidification set points, where knowing what your set point is and sort of looking at that through across the campus to see if it's actually matching what the recommended set point is, or is it a higher set point, and changing that it could be easily made through the building automation system as well. Sensor errors, again, we'll show you examples where the sensors, issues with the sensors could be easily identified and triggered through the trend analysis, and those helps you to again optimize the system as well. Overrides, most of you have seen alarms disabled in most cases. These simple fundamental things does impact the energy use in the building, and they should be monitored on a regular basis and then sort of resolved in a timely manner to ensure that by disabling these alarms, you're not sort of impacting the energy use in the building by doing that. And again, one of the other things that we noticed that like in some cases where we did the analysis, a lot of the trends were missing. Either they're not set up or they're not archived properly. So the fundamental thing about understanding the performance of the building goes through ensuring that these trends are available, and they're available for somebody to historically look at the issues, and then that helps you with the diagnostics of these systems. So ensuring that you have minimum trend set up, and those trends are archived for at least a year so that you can go back and take a look at those issues as well. So the optimization, like we talked about some of the kind of the key high level measures, but then it kind of goes to the implementation phase of optimizing these measures. So how do you actually implement these, right? What are some of the key areas of action that you can take today, which will help you start on that path of improving your facility? So HVAC scheduling, we talked about. Ensuring that your sensors are calibrated, that should be one of the fundamental things that your BAS contractors is providing you, and having those checks and balances, getting and asking them about those reports on the sensor calibrations is a key fundamental to ensure that those sensors are calibrated and you get the reports back. We'll talk about how you can include the rest of these sort of fan speed optimization and heat recovery system optimization as a means of your regular work within your BAS service contractor. So another element we also started part of this cohort project is to understand what are the existing service level agreements that exist within the space with the most of the controls contractors that are working with you as a partners. Typically, these performance contracts or these sort of service level agreements are based on reactive maintenance, which means that something happens in your facility, a valve breaks, a control sensor breaks, you put that as a list of the items, their tech comes in, they fix those items, and then they come in for the next visit, and you have the list ready for them, and then continues on. The aspects around the energy and emissions is typically not part of those conversations, and it's generally missed as a part of that opportunity. So what we are trying to do here is whether there's an opportunity to consider enhancing these service level agreements to include aspects for energy where the controls contractor not only sort of looks at your list of items that needs to be fixed, but also they look at on a regular periodically basis whether your economizer for the system is working or not, whether your static pressure resets are working or not, whether your HVAC schedules matches with the occupancy schedules or not. So that is a shift in based on the current SLAs that are currently signed, from making them to more of a sort of a performance, or including the elements of energy into those SLAs. And we have some recommendation based on that, and happy to have your feedback from anybody on that call to see whether and how we can kind of enhance this. So energy is not sort of omitted in these contracts, and it's reviewed on a regular basis, so we can make sure that the savings are remained. The other part of this is you can kind of, if you look at these three circles, you got to have somebody that within your organization take the ownership of this work. So having those people provide with the regular training and providing them with an opportunity to kind of have a role that defines a part of their job has to be taking ownership around energy and emissions. So they are responsible to make sure that the elements of the BAS is optimized, and they are engaged with the controls contractor to do that. So routine check is also obviously a key to ensure that the checks and balances are in place within the contract, or even also in operations teams, to ensure that the savings are achieved, they're sustained, and they continue to sustain. Then having some sort of a tools to see this information readily, whether you want to use existing building automation tool or you want to use another tool that would help you identify these opportunities and also help you continue to monitor them and to sort of do the M&B on these. So having some sort of a enhancement within that your current tools that would help you see all of these measures implemented and then sustain as well. So one of the things we're recommending is the appendices, which includes these samples. So this is just a sample. We have another sort of a big list of these optimization checklists. So this is something you can use and work with your, either you have an in-house team or you have a building automation controls contractor who could go through this checklist on a periodical basis and generate some sort of a very easy sample report that tells you that this work is complete and here's an outcome for that. So example on the right-hand side is a sort of a 1 page or less than half a page report that suggests that this particular system was tested for a static pressure optimization. The initial set point was 1.5, and after the test was completed and the optimization was complete, it was dropped to 1.1. As a result, the fan VFD from 62% dropped to 41%. So that's the change that happened as a result of implementation of this. So this list and with this testing report, you can sort of combine them too, and then use this on a periodical basis set those times requirements with your controls contractor, with your internal team, if they have a tech that could actually do all of these, and have them sort of report so that you have a standard process that's set up as a regular PM to look at the energy as well. Similarly, we talked about the minimum BAS trend data points. So that's also going to be part of the guide that should be archived and should be included or should be trended in your system. So you can actually go back and do the analysis on these and identify the further opportunities. So here are some results as we talked about with the optimization piece. So the first example here is a static pressure reset. And as you could see, the red lines at the top graph is your static pressure, or sorry, the VFD speed in 2024 when it was optimized, the static pressure was optimized, then the VFD speed, which is the green 2025, dropped. So the peak demand, which was, or the peak sort of VFD speed was 100%, and then it dropped to 80% once that static pressure reset was changed. So the bottom graph shows your static pressure set points. The red is a 2025 set point for a week, and then the green is the red is a 2024 set point for a week, and the green is a 2025 set point. Similarly, you could see the other measures before implementation of this. So the outside air damper on this unit was flat out open 15%, even when the unit was off. but when the implementation happened and this was identified, the damper position was then changed to 0%, which obviously result in any sort of air that was leaking into the system during the unoccupied period was avoided as a result of that. The humidification set point, again, easy fix. You look at all the humidification set point in your system, and this was identified to be a high set point, which was sort of enabling the humidifiers all the time, and the set point was changed. As a result, the humidification load decreased in that building. There was an issue with the mixed air temperature sensor. Even after providing you could see that this was identified as a part of the trend analysis. So the mixed air temperature was 16.46. The discharge was 17.14, even with the cooling valve 100% open. So the mixture was lower than the discharge with the cooling on. So that tells you there's an issue with the mixed air temperature. So these are sort of kind of a high level savings, which are kind of either in some cases it's already achieved, in other cases they're going to be implementing these measures. But you could see the payback on all these measures is less than 1 year. And in some cases it's less than a year. So most of these in most of these cases, the initiatives have helped to achieve significant savings with a lower cost that could be implemented in these cases. There are again incentive programs that are out there for different provinces, different sort of jurisdictions out there. So you can reach out to your individual contacts at ISO and Bridge if you're from Ontario, and respectively to other sort of provinces. The incentive programs will help you even provide or lower down those paybacks in most cases, because now you can leverage those incentive programs to either do initial investigations or to sort of ensure that you get that savings or incentives paid out as a result of the savings that you made on these measures. All right. With that, I'm going to introduce our panel for today. We have joined Aman here from Associate Director, Energy and Climate Change from Humber Polytechnic has joined us, and also Mark Mehdi, Senior Engineer, Energy and Efficiency Engineer, Decarbonization Leader, and LF Consulting. So Aman, let me kind of start with you. So you guys as a campus, as a college, have been involved in this research, right? And from your perspective, where typical, like you guys are at the top of the benchmarking chart in terms of the least amount of savings to be found, but there's still savings found in this. Like, where do you typically see from your college perspective, and also from other colleges that you currently see, or in general you see, where are some of the biggest and the fastest BAS optimization wins for the colleges and campuses to be had?
Yeah, sure. Actually, first of all, hi everybody. Happy to be on today. Yeah, I guess there's like one of the big themes in terms of wasting energy, in my experience, is around like conditioning spaces when nobody's there, right? Like how often does that happen? I can't believe how surprised I was, when I started working for an owner and kind of getting to experience that firsthand. So you touched on it a bit during your presentation. Schedules are really important. That's kind of a kind of fast and easy one. And like setting up schedules to have systems turn off overnight, weekends. Those are like the obvious ones. But what about stat holidays? What about other times the campus is closed? For example, Humber, we shut down between like Christmas and New Year's, right? That's a full week when we don't have to be delivering the same level of thermal comfort that otherwise we would have. So, I mean, there's opportunities around schedules. You just got to go in there and look, and it's worth, revisiting it on a periodic cycle. And then beyond that, like introducing simple sequences to turn things off when they're not needed. Like, it's very often, I might go into a building, you'll see a heating loop, like the pump's running in the middle of summer, right? It's just circulating room temperature water. Very easy to introduce a sequence to look at the outside air temperature and have the pump off, or look at the loop temperature and turn the pump off. And similarly, you'll have unit heaters with the fans running in the middle of summer. The same thing, put it on an outdoor reset, have it off, right? I think another big win for us at Humber has been around introducing the integration of our lighting occupancy sensors into our BAS. So again, it's around this theme of turning things off when people aren't there. So our automation system now knows when the space is unoccupied. And so that allows us to, close the damper on the VAV box, go to a setback temperature, the fans start to ramp down, the plant equipment, the boilers and chillers start to stage down, right? And we start to compound savings that way. And so we've got like a fancy lighting control system that's networked that does that integration, but we used to do it even before we had that, right? Even when we had local occupancy sensors, we used to run a wire off a dry contact on an aux sensor to our VAV box controllers, and then the BAS would get the occupancy data that way. So I mean, you don't need a fancy lighting control system to do this sort of stuff. But yeah, these are the big easy wins, I think. Just having things not running or ramping down when people aren't there.
Yeah, I mean, I'll get back to. I have a follow-up question on this because I know we touched on the easy ones, and you guys have done is develop a standardized set of sequence, and those helped you to sort of trim down some of the cost of implementation across those. So let me hold on to that thought for 1 second. I'm bringing Mark here into the conversation. So Mark, you've worked on these 2 colleges. You've done a lot of the analysis, reviewing the trend logs, and finding these opportunities within these systems. How do you sort of what are some things that we can share with the colleges that they can identify these issues and also systematically fix them? Like what sort of engagement would they need from the teams? And there's some easy ones that they can fix. Like, what's your experience on that?
Thank you, Amandeep. Yes, exactly. This is what we try to do by putting up these appendices. So we're trying to help the teams move from not just finding issues, but also solving them consistently. So what we actually see in the BAS reviews, that it ends up with a list of good observations like extended run hours, missing resets, a list of alarms, maybe overrides, lots of things like that. But what we find typically is it lacks a structured way to act on them. So this is what you explained about appendices. We've included mainly Appendix A and B. They try to provide a summary of what are the typical applicable measures for each and every system, like going from ventilation to heating and cooling and others, and what we're trying to achieve out of each measure, and what are the data points typically needed to conduct the analysis. So once we go through that list, or whatever is applicable for any specific building, we might find out that there are lots of them are already properly working and positive, which is great, and some of them might reveal like something wrong going on with operations and would require intervention. And this could be like updates on sequences, or maybe something physical, like if we're talking about dampers, linkages, loose linkages, or sensors drifting, or damage. So it could be lots of things. So once these updates are made, we also, as you mentioned, we provided Appendix B, which is an easy way. It kind of provides a skeleton to conduct an easy way for measurement and verification to validate that these changes were actually successful. So the appendices we provided, like, they're not just a diagnostic guide, but it sorts of tackle QA, QC in the framework of optimization.
Awesome. Thanks, Mark. I think we talked about this, Aman. If this was easy, this would have been already done. And there's always things that are easy to do, which you touched on. Then there's elements of where you need more brain power and aspects. So how do you advise the colleges and universities that are on there, that are starting this journey or have started this journey around where to focus on, and then what are some of the strategies to, especially your examples around standardizing sequences and implementing those ones, how can they sort of leverage those and apply and trim down some of the costs that might be required to implement some of this, let's say, static pressure reset programming changes in the building? So what's your advice on that based on your experience so far?
Yeah, sure. So with some of these more complicated sequences of operation, I think the ultimate goal has to be to scale this across your portfolio and then to maintain those savings over time, right? And so I think the only way to do that is to standardize. And so like you alluded to, like I can give you an example of what we've been doing at Humber. A couple of years ago, we decided we wanted to build standard high performance sequences for all of our like built up air handlers with VAVs downstream. And so that system type probably covers 60% of our floor area, right? So if we could get it right on one air handler, huge opportunity to expand this across the board. So we used an ASHRAE guideline 36. That was our kind of our foundation. But you know, instead of just implementing the sequences in that guideline verbatim, we engaged our controls vendor and got their input. And as it turned out, they actually had somebody on staff that was on the ASHRAE Guideline 36 committee in the US. And so we got a couple of meetings with them. You know, we got to ask them a few questions, and that was really helpful. And then also through conversations with them, we got to understand, you know, some of the controls limitations with our older VAV box controllers. And so through that dialogue, it led us to simplifying the sequences that were in the ASHRAE guideline. So, you know, we're trying to get 90% of the benefit with, you know, half the work, right? As a theme there. You know, then we spent a lot of time with our operations team to develop, like, what are the graphics going to look like around these new sequences? What points need to be operator adjustable? What views do they need to be able to monitor these sequences over time, right? And then when we got towards the end of the pilot project, we spent a lot of time doing like performance commissioning. So we're literally going line by line on the sequence of operation and checking it against the trends on the automation system. And you know, a lot of times the equipment wasn't doing what it was supposed to, and so we had to go back to the controls vendor, have them adjust the code. So all this took much longer, right, than us just slapping together a sequence and having the controls vendor put it in. But in the end, you know, we had our standard sequences. We had our standard graphics for our operators. So they knew what to expect every time they'd go to an air handler on the graphics, right? It would always look the same. And the controls company had their standard code, right? And so now when we go to implement this on all the other air handlers, there's much less labor involved, right? It's and cost, right? Because of that. Because the controls technician literally starts with a copy and paste, and then they start tweaking and you know, renaming points and all that. But you know, you put the time in up front, right, and then you save it on the back end. Yeah,
I think this standardization is really important with anything, especially with the campuses and having similar systems across. You touched on a bit, and I think I need to sort of maybe if you can elaborate on that. What are the key ingredients for a team to deliver these? Like for colleges and universities, like how do they kind of take on these low-hanging fruits? And we know that exist across every campus and every colleges. How does that sort of internal team configuration looks like? And what sort of responsibilities do you think needed by the facility teams to kind of drive this process? Or maybe you can use your example, like how do you guys sort of manage this process of identifying, implementing that, so that there's a dedicated person looking at this, or somebody has in their role responsibility to kind of look at this and engage the resources that are needed? Like how do you suggest, or what's your experience around that, ensuring that this works get done?
Yeah, so I'd say like the stakeholders are, you know, the operators, the controls vendor, your consultants, right? Your energy consultants. But I think the ingredient that brings all this together and makes it work is like the in-house energy team, right? And it doesn't have to be a team, right? It could just be one person, but somebody that understands energy and understands operations, right? They're the one that can translate and be the liaison between all these groups, and make sure everybody's interests are catered to, right, in the project. So, you know, in my example, like, you know, our operations team, you know, they want to save energy, right? I mean, they're on board with all this, but we need to make it easy for them, right? So the graphics had to be done in a way that they had all the information they needed in front of them. We had to do training sessions with them so they understood how the sequences are supposed to work. And I think it's difficult to get that from the outside. You need somebody in-house that understands this stuff and can deliver it for the operations team in the way that they need to hear it.
And that's where I think we talked about that there's programs that could help, right? The ISO Energy Manager program could help. There's internal teams that there's a dedicated people that could be trained on this aspects of understanding the BAS from the energy perspective would help. Mark, question for you. You worked with a controls contractor during this process, and when you talk to them, most of the times the conversation around, oh, we know all of these measures, and we probably are implemented these across the campuses or the colleges, but we still see these opportunities exist. We still see there's a gap. What's your recommendation to the owners when they talk to the contractors around how do they bridge that gap? Like, what can they recommend the controls contractor when they find these opportunities to help them implement and then provide that information back to them?
That's exactly right, Amandeep. So most of the contractors we had discussion with as part of the study, so understand and are very familiar with most, if not all, of these measures. So these are not something new. They were there for a long time now, and those in the field consider these as basic or rudimentary. So actually, the problem is that they're rarely written as deliverables or like performance expectations. So what we found is that many gaps actually originate from missing direction, not the knowledge itself, not missing knowledge. So the BAS contractor typically focuses on functionality, not performance. So like, does this system properly work? Does the fan run? Does the valve modulate as intended? Are the overrides working? But no one clearly defined what optimized performance look like. So that's why the guide proposes embedding optimization into SLAs as one way of sustaining like performance. So if in case, for example, SLA now includes seasonal schedule verification, for example, or static pressure reset tuning, and overrides audits as part of preventive maintenance, then optimization now becomes part of the SLA. So in short, yes, most contractors do have the knowledge, but the difference is having this clear direction that is currently missing and needs to be provided, and the open access to data between both sides, like the client side and the contractor side.
Thanks, Mark. I think that's generally has been the case where the opportunities exist. Is just closing the gap on those opportunities and having those key checks and balances within the systems to ensure that the measures are implemented and there's means to prove the measures are implemented, and those are easy. Because one of the things, as we talked about the controls contractor, is that their concern has been that this this might increase the cost on the service level agreements, but because there's currently a perception that the performance comes with a risk, and the risk has to be carried by somebody, and the risk always include an increase in the price. However, I think this is something could be easily made into some sort of a checklist, which doesn't include a performance on a sort of a cost perspective, but a performance based on, are you checking the system regularly? Are those checks and balances are in place? So somebody from the college perspective and a university perspective have that information readily available to them on a periodically basis, that they could confirm all my systems are working as per the schedule. All my static pressure resets have been reset as per the schedule. My BAS sequence has been working, economizer are working on the system. So that would help sort of create that connectivity between the controls contractors who know what to do, but the owners then providing a clear directions what they expect out of this process. Any questions, Natalie, that I just wanna see, give me 1 second, and then if not, we have maybe.
Yeah, we have one question for Amam. It's about if we have occupancy sensors everywhere in the college.
Hey, yeah, thanks for the question. We've got maybe a third of the college on our networked lighting control system, right? And then the integration with the aux sensors are done that way. And then in the spaces that don't have the lighting control system, maybe half or a quarter of those spaces, they're done kind of the old school way, where the local aux sensor is tied in through the dry contact to the VAV box controller. So between both methods, maybe half the floor area is integrated. Every time we do a new building, we get the new control system, so that gets taken care of. Every time we do a renovation, it gets the lighting control system, and we do the integration. And so over time, we will tackle the entire portfolio, but we're about halfway there right now.
Thank you, Man. Thank you, Mark. This was very helpful. Thanks again for joining this panel. So we'll continue this dialogue. And again, as we said, this is sort of the draft version of the guide. So we're hoping that after this session, we'll get a feedback from people that are attending this call and incorporate into this guide. So let me continue. So the next step is, as I said, like if you are interested, and we'll publish the draft version very soon, if you're interested in providing us any feedback from what you heard today, we'll love to incorporate that and then work with you guys to understand the concerns or the questions that you have faced while implementing these measures, and provide any insights we can for you. So and our hope is that through this work, you're going to identify at least 2 to 3 measures as a pilot to work on your campus. And then if you do choose those, please let us know. We'd be happy to sort of work with you, document those, and then present that as a case study that would help encourage other colleges and universities to do the same as well. If you have any recommendations on the checklist, including on the appendix, if you missed any measures, please feel free to review and send back those recommendations. We'll be publishing this guide with feedback, and it will remain open for additional feedback for at least a few times, so we can incorporate all of that. And if you are not still subscribed to the announcement, so that would help you identify when the guide goes out, please do so. You can reach out to Natalie. I'll share the contact information after this. And again, if you have any further sort of requests around questions, collaborations with this project or additional projects, the core projects that we do, please do reach out, and we will we'll keep you in mind when we start on the new phase of these projects or additional projects that are connected to this kind of work. If you are a college or universities are thinking about joining the group, the Post-Secondary Climate Challenge Network, which provides you with data-driven, high-impact climate solutions, looking at individual buildings around target savings potential, reporting on the data, and then finding the best use business case for investment in energy efficiency, please contact Heather Bell. She's the Director for Program and Partnerships, and we can continue on that conversation, engage with you, and then hopefully provide you the benefit of this program. So thanks everyone again for for your time today. You can, again, this webinar is recorded, and you can find all the contact information for all of us here. And we hope to stay in touch with you, and I hope to hear back from you on the measures and the guide that would help you implement some of these initial initiatives and reduce the energy and emissions. Thanks again for your time this afternoon. Bye for now.